So hi friends, I am going to solve this question last day where you can still cross. So basically this is our daily question on the 30th June. So reading the question, we have given a one base matrix in which 0 represents the land and 1 represents water. Okay, so we have a matrix like this is a matrix in which 0 represents land and 1 represents water. Okay, then also we have a 2D array cells in which cells of I is equal to Ri comma Ci, and this Ri Ci is basically row and column which is filled with water on ith day. So if you will read this question, you will find that this was exactly the language of the question. This was exactly what they have asked. Okay, so here basically we are filling each cell of this matrix with water. So on the in this example input 1, we can see that on the day 1, 1 comma 1 is filled with matrix water. So 1 comma 1 cell of this matrix is filled with water. On day 2, 2 comma 1 is filled with water. On day 3, 1 comma 2, and on day 4, 2 comma 2 is filled with water. So basically we are filling each cell of this matrix with water. Okay, so what they have asked, you have to find a last day that is possible to walk from top to bottom. So basically we have to move from top to bottom, and we have to find what is the last day on which we can move from top to bottom. Okay, and after that you can travel in four direction. Okay, so we can travel in four direction, that is left, right, up and down. So basically reading this line we can see that we will use recursion or DFS to check whether we can travel to top to bottom in a particular matrix or not. So first thought which we can think about is that we can iterate on each day, and we will check, we will create a grid or matrix with the waters and land in row in each cell. Okay, so basically talking about day 2, so we have day 2 in which 1 comma 1 is filled with water and 2 comma 1 is filled with water. So the grid corresponding to day 2 is this. So we will check on that day whether we can move from top to bottom or not. So in this way we can maximize the value of day. We will check for the first day, if it is possible to move, then we will check for the second day, or then we will move to third day, and we will maximize the value of day in which we can move from top to bottom. So this was basically iteration in each element, each index. So another way we can use binary search. So I have shown here that we have cell in which on first day 1 comma 1 is filled with water, on second day 2 comma 1 is filled with water, on third day 1 comma 2 is filled with water, and on fourth day 2 comma 2 is filled with water. So basically this was a scenario of initial matrix where each element is filled with a 0, means each cell is a land. So what we can do that we will use binary search. So here we have some of the pointers of binary search, like this is left, okay, and this one is right, and corresponding to this left and right we will find mid. So the mid of 1 comma 4, 1 and 4 will be 2. So this is going to be our mid. So this blue pointer represent the left index, this red will represent the right index, and this black will represent the mid. So basically mid is on day 2. So we will check on day 2 whether we can move from top to bottom or not. So on day 2 1 comma 1 is filled with land water. Okay. On day 2 2 comma 1 is also filled with water. Okay. And rest is filled with land. Rest is land. Okay. So is it possible to move from top to bottom? Yeah, we can move from top to bottom. 0 comma 0 is land. 0 is land, so we can move from top to bottom. Okay. Now moving forward, if we can move, so checking for further cases, so we will increase this value of left to mid plus 1. So left will be 3, and corresponding to this left and right we will get mid as 3. Okay, so we will check for the day 3. So on day 3 we can see that first row is filled with water, 1 comma 1 is filled with water, 1 comma 2 is also filled with water, and 2 comma 1 is also filled with water. So you can see that land is 2 comma 2. Okay, so you can see that it is not possible to move from top to bottom. So in this case it is not possible to move from top to bottom. So we will, what we will do, we will decrease this right to mid minus 1. Okay, right is equal to mid minus 1. So in this case we can see that the value of left is greater than value of right. So it is a case violation in case of binary search, and in this case we will break our loop of binary search. So we can see that first we were iterating over each index, and now we have to iterate over only log of n index, where n is the size of this cell. So it will reduce the time complexity. Let us try to write the code for this question. So basically we have index, let us take a variable n, sorry, which is nothing but size of cell. Okay, and let us have two pointers left. I will write L as a left, so left will be 0. Since array or a matrix is a 0 based, so we will use 0 based indexing in our case. So L is equal to 0 and R is equal to n minus 1. Okay, so doing binary search, while L is less than equal to R, we will have a mid integer, mid pointer, which is nothing but left plus right minus left upon 2. Okay, so we have this. We will check for this case if it is possible to get an answer or not. So basically I will declare a variable answer with a 0, and if whenever we get the value, we get an answer corresponding to particular mid, we will maximize this answer. Okay, so on the midday, so on midday, like, we will, what we will do, we will fill all the grid, all the cell of a particular matrix with water. Okay, so let us get our matrix, vector of change matrix, and the size of this matrix is nothing but row comma column. So basically I'm going to initialize it with 0. Okay, so on midday, so I will do one thing, that I will change the element, change the cell of this matrix to 1, corresponding to day 0, day 1, day 2, whatever we have filled, which whatever row we have filled with water on each day up to midday. Okay, so for int I is equal to 0 to mid, we will fill the matrix with water. So the row will be int r is equal to nothing but cells of I minus 1, and c will be, okay, sorry, cells of I comma 1 minus 1, and c will be cells of I comma, okay, it is 0 base, so here it will be 0. Okay, and this will be 1 minus 1. Okay, so this this R comma C will be filled with water. So matrix of R comma C is equal to 1. So we have a matrix which is on day mid. So if day is equal to mid, we have this matrix. So we will check on this matrix like if the value of mid is 2. So here mid is 2. Okay. Here mid is 2. So the corresponding to this matrix we have is 1 0 1 0. So that's what it is written here. So we have got the matrix, and now we are going to check whether it is possible to get the answer in this day or not. So I'm declaring a variable bool can possible is equal to 0. Okay, and we will, so basically we are going to start from the first row. Okay, so we will check whether it is possible to move from first row to the last row or not. So we will have a DFS function. So basically I'm going to write int for first, for each column of first row. Mm, okay, I will start my DFS. Okay, so I will run a DFS function if it is possible to have an answer corresponding to from this row or not. So this DFS will contain 0 comma j comma id comma what else, just this. Okay, so here we have another recursive function DFS. So the entities of this function is int row, int column, and int, this R and C is current column. Okay, and row and column is whatever we have given in this function as a parameter, and vector of int and grade. Okay, so basically I have to pass row and column here also. Okay, so first of all we will check our boundary conditions. So if this R and C exceeded the boundary, we will return 0 or return false. So if R is less than 0 or R is greater than equal to row, or C is less than 0 or C greater than equal to column, then we will return false. Also, if we are on a particular cell which is not a land, so create of R comma C, if it is not land, then also we will return false. Okay, otherwise we will mark it as to marking it as a visited, we will convert R comma C to -1, which means we have visited this row and column, and we will move in each direction. So in case, in order to move in all direction, we have a vector of pair of integer named direction, and here are our all four directions. Okay, so you can see here are our all four directions. Okay, so moving in all directions, we will get new row or column. So we have nr is equal to row plus cle dot first, which is our first new row, and nc is equal to c plus cle dot second, which is our new column. So we will run our dfs function for this new row and new column, and if we got answer corresponding to this, we will return true. Okay, in base case there is also one function that if r is equal to row minus 1, like we reach the last row, then we will return true. Okay, and else we will return false. Okay, so this is what a DFS function is. So if we got here true, so we can say that it is possible to move from top to bottom. So we will change can possible to 1 and break. Now if can possible, what we will do that just in this case, if it is possible to move from top to bottom, so what we will do, we will first store the value of this mid, because corresponding to 2 we got the answer. So we'll store the value of 2 in an answer, and what we will do, we will increase the value of left pointer. Okay, and we will check further. Okay, so what we will do, answer is equal to mid, and what we will do, left is equal to mid plus 1. Otherwise, what we will do, right is equal to mid minus 1. Okay, so we are done with our part, and we will return answer plus 1. Plus 1 because we were solving on zero based indexing, but they have asked for one based indexing, so we have to add 1. Okay, wait, there is issue. So let's check whether our answer is correct or not. Mm, what is the issue? Greed. Okay, where it is? Okay, here it is. Okay, basically we are using matrix. So okay, okay, also left, it is not left, it is L, and this is R. So these are some kind of mistakes. So you can see that our test cases are passing. Just let's see on main cases. So yeah, all the cases are passing. So you can see that how it is possible to solve this question using binary search and recursion. So this is the benefit of binary search, that we have less time limit, and if we have used the iteration, um, there may be TLE. Okay, so this is the answer. Once again, I am going to repeat how I have solved this question. So basically, I have used binary search on this day, and I have gone I go I have gone on mid, and I have checked on the this day whether it is possible to move from top to bottom or not, and if it is possible we will check for more cases, otherwise we will return our answer, or we will decrease the value of right to mid minus 1. Okay, so what, that's what we have done here. If it is possible to get answer, we will increase the value of left is equal to mid plus 1, and if we cannot get an answer, we will decrease the value of right to mid minus 1. So basically this part was binary search, and this part of recursion, which was used to check whether it is possible to move from top to bottom on particular day or not. So that's what our answer is. So I hope it helped you. I have tried to explain it in proper way. I'm also add the link of my solution in description, you can also see it from that. Thank you.